Okay, for this second part of the recording, we're going to be looking at solving the inequalities as well as the secondary problem that we had on our test review. So here's our first problem. We have the absolute value of x minus 5 needs to be greater than 8. So before I get started on this, I just kind of want to look at a small graphical approach. Now we know that this transformation is a function that has moved right 5 units. So I end up with a graph that looks like this. The second thing we're worried about is where is this line, or where is x minus 5 above the line y equals 8. On this problem we can see that we have two sections of our graph where the function is more than 8. What this is going to tell me is it could be either over here in the left section or it could be over here in the right section. Either or works. And so what this is actually going to cause for us is what we called a disjunction last week, because it could be in either category. So when we solve this algebraically, we're going to start off with x minus 5 is greater than 8, or x is greater than 13. That was a very easy part of the problem to solve. Now I need to go ahead and set up the second one. Our second one would be x minus 5 Now this time when I switch a sign of a value, I also know that I have to switch the direction of my inequality. So when I do so, I've got x is less than a positive 3. So what that is telling me about this graph is right here, or negative 3. And negative 3 is right when it hits this line. At positive 13 is the second time when it hits the line. So if x is more than 13, it's going to be over here. If x is smaller than negative 3, our y values are going to be over here. Both give us a result above the line y is equal to 8. So now when we look at our actual solution, we'd have x is greater than 13 or x is less than negative 3. So our second problem, we have 6x plus 1 is less than or equal to 17. So same kind of deal as the last problem. I want to start by looking at a graph. So when I look at this, I'm going to end up with a function that's been shifted left 1. And the second thing I'm going to be looking at is the line y is equal to 17. Since I'm worried about where the blue line is underneath the red line, and I can easily see that it starts here, goes down, comes back up, and then it stops. So this is going to cause some issues for us when we're writing our answer. We need to basically say x, as long as it's in between these two values, a and b, as long as it's in between these two, it's going to be okay. And when we write our inequality, it's going to reflect x being in between two values. So we start off with 6x plus 1 is less than or equal to 17. When I solve this, I've got 6x is less than or equal to 16. Or x is less than or equal to 16 over 6, which would reduce to 8 over 3. Now when I go to solve my second half, I'm going to have 6x plus 1 is now greater than or equal to negative 17. So just like on the previous example, I still must change the direction of my inequality when working through the second half. So that's going to give me 6x is less than or greater than or equal to negative 18, or x is greater than or equal to negative 3. So what that's going to tell me, I can kind of see that this would be negative 3, and this would probably be whatever the 8 over 3 is, so 2 2/3. So when I go to actually write my inequality, I'm going to start with this. I see my smallest value here is negative 3. Negative 3 needs to be less than or equal to x, which is the same as what I said right here. However, I also see right here, x needs to be less than or equal to positive 8 over 3. So, like I was saying earlier, we're saying x values in between negative 3 and positive 8/3 are acceptable for this inequality. Okay, our final example of an inequality. We've got absolute value of 12x minus 10 plus 6 is less than or equal to 8. So when I go to solve this problem, what I'm going to start off with is I'm going to start by solving for the absolute value. So I need to get rid of this plus 6. So I've got 12x minus 10 is less than or equal to positive 2. So when I separate, I've got 12x minus 10 is less than or equal to 2. So when I solve this, I add 10 to both sides. And so that gives me 12x is less than or equal to positive 12, or x is less than or equal to 1. Now the second equation, we've got 12x minus 10 is now greater than or equal to a negative 2. So when I add 10 to both sides this time, I've got 12x is greater than or equal to a positive 8. Or x is greater than or equal to 8 over 12, which would reduce to 2 over 3. So let's go ahead and take a look at what we've got. We've got 2 over 3 is the smallest value. Needs to be less than or equal to x. And x is less than or equal to 1, which gives me my solution to my inequality. And graphically, this would look very similar to the last problem. Okay, so our next problem is kind of a two-parter. We've got if 4x minus 3 is equal to 2, and 2 absolute value of 1/2 x plus 5 minus 6 is equal to negative 3, what is the smallest value of the product xy? So we have two equations that we need to solve here. We're going to have 4 different values, and then we're just going to have to find out our different products. So I'm going to start with 4x minus 3 is equal to 2. So I'm going to solve my equation like normal, where I've got 4x minus 3 is equal to positive 2. 4x is equal to 5. X is equal to 5/4. The other situation I could have is 4x minus 3 is equal to negative 2. 4x is equal to positive 1, or x is equal to 1 over 4. That's my first possible. These are my first two values of x that I'm going to need to check. Now I need to check for y. So on y, I have the equation 2, absolute value of 1/2 y plus 5 minus 6 is equal to negative 3. So I've got 1/2 y plus 5 is equal to a positive 3, or 1/2 y plus 5 is equal to 3 over 2. So I'm going to solve my positive version, where I've got 1/2 y plus 5 is equal to 3 over 2. So I'm going to start by subtracting 5 on both sides. So I get a common denominator. This would be 10 over 2. So 1/2 y is equal to negative 7 over 2. And then to cancel out a fraction, I'd multiply both sides by 2, or y is equal to negative 7. There's my first solution. Now when I come up with my second solution, I will need to work with a negative 3/2. So my second solution, I have 1 over 2, y plus 5 is equal to negative 3/2 this time. So when I subtract, I've got 1/2 y is equal to negative 3 over 2 minus 10 over 2, which in this case would give us 1/2 y is equal to negative 13 over 2. I multiply both sides by 2. I'm left with y is equal to negative 13. So between these different values, we need to find out which one gives us the smallest product. So I had x is equal to 5 over 4 and 1 over 4. I had y is equal to negative 13 and negative 7. So the different products I have available, I would have negative 13 over, times 5 over 4, which will give us negative 65 over 4. And I have negative 13 times 1 over 4, which will give us negative 13 divided by 4. I would have positive 5 over 4 times a negative 7, gives us a negative 35 over 4. And then we'd have positive 1 over 4 times negative 7, will give us negative 7 over 4. So when I put these values in the calculator, we can kind of see that negative 65 over 4 or negative 16.25 would be the smallest value. Okay, because this would only be a negative 1.75 over here. On a number line, negative 16 is much smaller than negative 1.75.